are most welcome, ladies and gentlemen, to Real Impartation Moment on Tuesday Night Anatomy with Daniel Okwan. Today's section, we continue with our concepts regarding the general embryology. My friends, if you've not watched all the previous videos that I've done, yes, regarding gametogenesis by way of oogenesis, spermatogenesis, regarding fertilization, regarding the process of cleavage, leading to, of course, the formation of the blastula, to be implanted. My friends, I have all those videos there in the playlist named Developmental Anatomy. So kindly go in there and find all these videos and watch. My friends, last week we looked at what happens to the conceptus during the second week of intrauterine life. Something which has this kind of mantra, the week of two, so that there were certain important things which were formed in pairs. Last week we got to know that, yes, for instance, the trophoblast, which will eventually become the future placenta, very important in the nourishment of the embryo and the fetus, yes, got differentiated into two by way of the cytotrophoblast and, of course, the syncytiotrophoblast. Yes, I'll take my time and go through all those things for you, so that then you see the nutrition of what you call the embryo and the fetus. We look at that one. My friends, importantly, one thing that we saw which formed, in two was actually the embryoblast. If you remember, the embryoblast got differentiated. The first group of cells, which are very close to, of course, something we call the, very close to what we call the blastocyst, yes, of the what we call the blastocyst, yes, got, differentiated, to become what we call the hypoblast. And of course, the remaining cells of what we call the embryoblast eventually became these kind of columnar-shaped cells, which we call them the epiblast. Yes, that's what we saw. That was also another thing which also formed, which also demonstrates that in the second week of intrauterine life, we have things happening in pairs by way of the, embryoblast differentiating to become hypoblast and, of course, epiblast. We saw that. Yes, my friends, one useful thing that I want to say over here is that I am interested in what happens to the embryo proper by way of the embryoblast. So in the second week of intrauterine life, the germ disc, that we formed from the embryo proper was actually what we call the primitive embryonic disc. Now, if you remember, we said primitive embryonic disc, and that is why we said that the hypoblast was the primitive endoderm, and then, of course, the epiblast was the primitive ectoderm. Because at the end of the day, I told you something, that they were not the final things; they will eventually be replaced, with the definitive forms of these guys. So my friends, today I'm more interested in looking at what happens to this hypoblast and the epiblast, yes, in the third week of intrauterine life. Now, importantly, in the third week of intrauterine life, we form the trilaminar embryonic disc. The trilaminar embryonic disc. Something you are aware already, that we form ectoderm, we form mesoderm, we form endoderm. But from where? We want to look at the process leading to the formation of the trilaminar embryonic disc. And my friends, that process is something we call gastrulation. Gastrulation. We are going to see that in the third week of intrauterine life. Importantly, what is happening to this embryoblast, which got differentiated into what we call hypoblast and epiblast, that process leading to the formation of the definitive or the final. The reason why we call these guys definitive, embryonic disc or layers of the embryo is that at the end of the day, whoever you are, importantly, all those important structures in your body, came from these trilaminar embryonic disc of the embryo. Yes. And for this reason, we want to call them the definitive layers of the embryo proper. Yes, that's what we are going to see. So my friends, the process leading to that conversion of the bilaminar embryonic disc to become trilaminar definitive embryonic disc is what we call gastrulation. For this reason, the product, the trilaminar embryonic disc that we form, that product will be called gastrula. Yes. the process of gastrulation, so that product formed from that process will be called gastrula. And therefore it tells me that gastrula will be endowed with a trilaminar embryonic disc. So that's exactly what we want to see over here. But for us to look at this, then we need some concepts from what we learned last week. So my friends, pay attention and closely understand these things. So we are looking at week 3 of embryonic development, week 3 of intrauterine life. And my friends, this week 3 of intrauterine life, the key thing I want you to know is that we are looking at the process of gastrulation. Gastrulation, importantly, gastrulation. Gastrulation. Now, in the second week of intrauterine, now, just free your mind. Let's just take away what we call the trophoblast, bio of the side trophoblast. I'll take them separately later. Let's take away what we call the amniotic cavity. Let's take away what we call the secondary yolk sac. Let us also take away what we call the extra embryonic mesoderm, the 2 differentiations, take them away. But let us focus on what happens to the hypoblast and the epiblast. So we saw that yes, there's going to be this kind of hypoblast and epiblast. Okay, now this is the axis. Yes, so we have this as the axis, and I told you that there's going to be some columnar shaped cells. And my friends, that columnar shaped cells which were above over here, what are these? These represent the cells of the epiblast, okay? So cells of the epiblast, we have them over here. Now, these cells of the epiblast, so this is the epiblast cells over here, and then we said below those population of cells, okay, will be what we call the hypoblast. Now let me just demonstrate these guys. This is the hypoblast. And one thing that we know is that unlike the epiblast, the hypoblast is rather cuboidal cells. This is the hypoblast. Yes. Now, something interesting happens. Now, once we move away from the second week of intrauterine life, just entering the third week of intrauterine life, something happens. And that is the presence of some of the cells, okay, of the hypoblast at one end. So it could be at this end or the other end, getting converted to become columnar. From cuboidal cells, okay, from the cells which we expect to be cuboidal, now they will get converted to become columnar cells. So let's say over here, at one end of the embryo, some of the cells of the hypoblast, they become elongated. So they become elongated, so you may see something like this. Yes, my friends, that's what happens. Now, once we form this guy over here is something we call the procaudal plate. Now, the elongated cells at one end of the epiblast, okay, is what we call what? Procaudal plate. So let me just put that one over here for you. This guy is known as the procaudal. The elongated cells of the hypoblast at one end. My friends, importantly, this procaudal plate is doing something, has some kind of significance over here. And my friends, the significance is that once we see the procaudal plate, it tells us that this becomes the cranial end of the embryo. Now please try and understand this one for us. This becomes the cranial end of the embryo. Yes. Now already, one thing we will know is that these epiblasts, they are the dorsal aspects of the embryo, hypoblasts are the ventral aspects. But we are talking about the cranial, the head end of the embryo, and then the tail end of the embryo, okay, will be defined, okay, by who? By, of course, this procaudal plate, or it will be decided by this procaudal plate. So that at this point, I know there's the cranial end of the embryo. So there's the head end of the embryo. Head end of the embryo. It therefore tells me that the opposite end becomes the caudal end of the embryo, the tail end of the embryo. So this area now becomes the tail end of the embryo. So this procaudal plate is helping us to establish the craniocaudal axis of the embryo. Yes. My friends, one thing that we also see is that once there's the head, one thing that is also known is that this same procaudal plate will become the buccal-pharyngeal membrane. Something we also call the oropharyngeal membrane. The future mouth of the embryo. Yes, so that is one thing. After all, that's the cranial end, head end. That's where we have the mouth. So this procaudal plate will eventually become the future mouth of the embryo. And therefore, we have the opposite end, being the tail end. Yes, that's what we see. But my friends, let me be quick and tell you something. Wait, something I'll come to, but let me be quick and tell you something. Now, establishing the longitudinal axis proper of the embryo will not be by this procaudal plate. My friends, that one will be by something we call notochord. I'll come to it, we see it. Notochord. Yes. And my friends, this notochord will also be useful in telling us the laterality of the embryo. This one is not able to tell us whether this part belongs to the left or this part belongs to the right. So the laterality, the left-right aspects, distinctions of the embryo will be defined or will be determined by something we call notochord and not by this procaudal plate. I'll come to it anyway. So this is what we have. Now once this happens, another event takes place. Yes. Now elongation of some cells of the epiblast at one end of the embryo has taken place. We've seen that this therefore becomes the cranial end by the presence of these procaudal plates. Therefore, this is the caudal end of this embryo. Something else happens. And this happens to cells of the epiblast. Yes. Now, at this point, let me tell you something. The trilaminar embryonic disc, which will be derived from the bilaminar embryonic disc, will actually, in essence, will be coming from cells of the epiblast. Some cells of the epiblast. Why? Because there's going to be some rapid proliferation of the cells of the epiblast over here, this time from the caudal end towards the cranial end of the embryo. Importantly, yes, that's what I want to know. Now, so pay attention, something is going to happen apart from the procaudal plate formed over here in the hypoblast, in the epiblast, from the tail end. Now, this time not from the head end, from the tail end, we are going to see some rapid proliferation of the cells of the epiblast going towards the cranial end. So let me just show you something by cleaning these areas to show you how the proliferation will take place. Let me just show you. Now this proliferation is not taking place in the entire embryo. No, it's taking place in the midline of the embryo. Midline of the embryo. These events taking place in the midline of the embryo. And that's what we see. So that we see some population of cells of the of what we call the epiblast, proliferating rapidly, and going in the midline towards the cranial end, so that at the cranial end, what they are going to do is that they will form some kind of nodular mass over here. So that's what we see. Schematic, I'm trying to explain this one for you. This kind of movement, the proliferation began from the caudal end of the embryo and moved towards the cranial end. This proliferation of midline cells of the epiblast toward the cranial end is something we call primitive streak. Primitive streak. Guys, this is the primitive streak. And it is this primitive streak which will be very important in giving rise to these, trilaminar definitive DM layers. Very important in doing that. Now, this primitive streak, as I told you, gets into the cranial end over here. What will happen is that they begin to move and form some kind of nodular mass over there. And my friends, this guy is something we call primitive knot. Knot. Something you may also say node. Primitive knot or primitive node. And in most cases in your exam, okay, you may not see primitive node, primitive knot. It has an eponym. And my friends, that eponym is Hansen's node. Hansen. Hansen's node. Yes. That's one thing that we are going to see. So, primitive streak, and at the cranial end, that elevation, nodular mass over there, is something we are calling primitive knot or Hansen's node, which will contain a pit, primitive pit. Which will, contain a pit, primitive pit. That's what we see. This primitive node will contain a pit known as primitive pit. But this streak, primitive streak, will be running through a groove. And therefore that groove will be called primitive groove. You will see that. I will draw it again and show you that one. So that's one thing that we've seen. Proliferation of cells. So that if I should take, a dorsal anterior view of a cross section of the embryo, let's say if we cut through it, then what are we going to see? Let's take a cross section of it, and then we can look at the dorsal aspect, and of course, the anterior aspect over here. Let's see what is going to happen. This is something we are going to see. Just to show you that. Just trying to explain how the so-called streak happens. So, they've taken a cross section through this embryo. So that this time around, what I'm trying to show you here So over here, I'm having cells of the hypoblast. Cells of the hypoblast. And then over here, I have some cells of the epiblast. Now the epiblast, they are columnar cells. And then cells of the hypoblast, cuboidal. So we've taken a section through it. Now this time around, what we see over here is that we are seeing the primitive streak. So that the streak, from the streak, we see some cells coming out. They are coming from this streak. Now, one thing I want you to know is that this is the primitive streak. And then this becomes a primitive node or a primitive knot, Hansen's node. That's what we see. So that these cells, okay, which are coming from the streak in the midline, they are proliferating rapidly. And what they are going to do is that first, they are going to displace the cells over here. Which are these cells? The hypoblast. Of course, over here there will be that kind of, secondary yolk sac over here. So they are going to be displaced out. So one lesson is that in life, if you are not supposed to go and sit somewhere, a place that you are not destined to be, they've not prepared that place for you. When you go and sit there, you will be displaced. So the hypoblast cells, they are not the definitive, they are primitive. So it means that they will be displaced. By what cells? The first population of group of cells coming from the streak, from the primitive streak, okay, running through the primitive group. They are going to displace them over here. So this primitive streak will first form. So there's also one important question that you can be asked. That as in the germ layers that we are going to form, the definitive germ layers. Let me put it over here. The definitive germ layers from the streak. In what order are we going to form them? My friends, the first one that we are going to form, because we are going to displace the hypoblast, and I told you that the hypoblast was the primitive endoderm. It means that the first one that we are going to form will be the definitive endoderm. So the first germ layer from primitive streak will be endoderm. Yes. And then the second germ layer, okay, so once we form this, here the streak, okay, we display these guys, okay, from here, these cells over here, come and fill it. Definitive endoderm, and then some population of cells from the streak again will come and fill. Okay, now this time between, of course, the endoderm, and then of course, the cells of the epiblast. And then we will form what we call the mesoderm. So the second germ layer that we form from primitive streak will be, of course, mesoderm. Sometimes some people may write ectoderm. No, the answer is mesoderm. That's one thing you got to know. And then the third group of cells, the remaining cells of the epiblast, okay, will also, give rise to what we call the ectoderm. Ectoderm. Okay, so that the third one that we form will be ectoderm. Yes, that's what we see. And we formed, our three, definitive germ layers. Yes, that's one thing we see. And so one other thing that I want you to know is that there is something also striking that I got to tell you. Is that, yes, endoderm, no problem, we form it. by the displacement of hypoblast cells. Mesoderm will form in between. Ectoderm, yes, no problem. The remaining cells of the epiblast forming it. My friends, something interesting happens to the mesoderm and is worth acknowledging. And that's the next thing I want to, schematically show for you, so that when we look at it, then that becomes the end for today's class, and we will continue with the remaining ones, yes, next week. Now, at this point, in the 3rd week of intrauterine life, the embryo is slipper shape, looks like a slipper. So something that when we draw, okay, so that's how it looks like. Okay, so that's what we see. Now, the first thing that we need to acknowledge was that I told you something, that there will be this kind of structure over here. Yes, something that we told you that is the procaudal plate. Now here I have the procaudal plate. So assume you are looking at the dorsal aspect of the embryo. So we are looking at it this way, dorsally. Procaudal plate. My friends, one thing is that once you know that this is the procaudal plate, then it means that this is the cranial end of the embryo, the head end of the embryo, and therefore the opposite, the tapering end, becomes, the tail end of the embryo. It therefore tells me that the cranial end of the embryo will be broader than that of the caudal end of the embryo. Now, I told you something, that the procaudal plates will give rise to something called the bucco-pharyngeal membrane, and that's one important thing. That's what I want you to put over here, bucco-pharyngeal. Something we also call oropharyngeal. Membrane. Yes, bucopharyngeal or oropharyngeal membrane, the future mouth. So that's the future mouth. So it will give rise to opening of mouth, future opening of mouth. Yes, that's what we see. Now, if you've seen future opening of mouth over here, then it means that at the caudal end, we have another opening. And my friends, that opening will be a bit smaller. Will be a bit smaller, okay, compared to the future opening of mouth. Yes, we know. The anal canal opening will be a bit smaller. And this guy over here, okay, will be called cloacal membrane. And that is, of course, the future opening of what we call the anal canal. Yes, this is what we are going to see. Now, I told you something, that there's going to be that kind of streak. Now draw this. Now, my friends, there's going to be that streak. I told you that that streak will begin from the caudal end, and it's evident over here towards the cranial end. So it will be going this way. So, my friends, this guy over here that I want you to put down is the primitive groove. And this primitive groove will contain the primitive streak, will contain the streak. Yes, that's what you see. And then also I told you that getting to the cranial end, okay, there will be that kind of nodular mass over there. And my friends, that nodular mass over there is that thing that we call Hansen's node, okay, or primitive knot. Which will contain the primitive pit. Now that's what you see. Now one more thing. From the cranial end of this primitive knot, which of course this primitive knot will arise from this primitive streak. Yes, the cranial end of the primitive streak is the primitive knot. So at the cranial end over here, we see something. Let me use a different, perhaps a different color to show. Or let me use the same color that is coming from this same thing. So this is that guy. There will be another structure coming out, okay, in this manner. From the cranial aspect of the primitive knot, we see this guy. And my friends, this guy is something we call notochord. 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 Yes, that's what we see. Notochord. So it means that if you are asked that notochord, where did it arise from or where does it come from? My friends, your answer is primitive knot or the Hansen's node or primitive node. Yes, that's your answer. In case you don't have that one there, then of course primitive streak should be your answer. Because at the end of the day, the primitive knot came out of the cranial aspect of the primitive, streak. Okay, so that is, one thing that we see. Now, if you look closely at this primitive, notochord, importantly, is forming the longitudinal axis of what we call the embryo. And it forms the basis of the axial skeleton in the embryo. Yes. And one important thing that we see is that with the presence of this notochord, we are able to establish the laterality of this embryo, so that now I can confidently say this is the right side and this is the left side of the embryo. Yes, I'm taking a dorsal view of it, superior view of it. Okay, so that's one thing that we see. The laterality of the embryo will define it will be by the appearance of what we call the notochord. That's one important thing that I want you to know. Now, my friends, we say that all chordates will have this notochord. Okay, this cord-like structure. Now, this notochord, primitive knot came from primitive streak, so to speak. And primitive streak is ectodermal, or is coming from the primitive ectoderm by way of the epiblast. But my friends, it goes through the mesoderm. Okay, so this notochord will be running through the mesoderm. You are seeing what is happening in the mesoderm. We'll be running through it. Okay, so we can say that yes, although it is coming from what we call the primitive knot, which will be coming from the primitive streak, which will be coming from cells of the epiblast, which epiblast cells are primitive ectoderm. For this reason, you can say it's ectodermal structure running through the mesoderm. Or you can also say it is, of course, mesodermal structure, because at the end of the day, all these three germ layers will be coming from cells of the epiblast. Yes, that's why it's what I want you to know. Now, we will see something that this notochord. Now, when we go to neurulation, I'll be explaining what happens to the fate of all these germ layers. We will see that, and we will understand, the role of this notochord again. But for now, one thing I want you to know is that this notochord, after establishing this, this laterality of the embryo, after forming the basis of the axial skeleton of the embryo, okay, then one important thing that I want you to know is that the remnants will form what we call the nucleus pulposus of the intervertebral disc. The remnants of the notochord will form the nucleus pulposus of the intervertebral disc. So it's important in forming components of the intervertebral disc. So the first thing is that the remnants, I'm interested in the remnants, will form nucleus pulposus of the intervertebral disc. Now, not only that, one other thing that you should also be aware is that it will also form one ligament, which you call it apical ligament of Dens. Now, for some of you, if you look at some aspect of the skeletal system, where you looked at bones of the vertebral column, you might have come across C1, C2 things, okay, bones of the cervical vertebrae. The first cervical vertebrae is, of course, the atlas. The second one is axis. Now, you realize that the axis has a tooth-like process, which you call a Dens or the odontoid process. So there's some kind of ligament extending from the apical portion of this odontoid process, and that ligament is what we call apical above ligament of Dens, or apical ligament of the odontoid process of axis. Is also coming from the remnant of what we call the notochord. Now, not only that, there's one ligament, okay, related to the vertebral column, which you call a posterior longitudinal ligament. Posterior longitudinal ligament. Now, I'm not interested in the posterior longitudinal ligament. In the atlanto-occipital region, the posterior longitudinal ligament over there is given a special name. Something we call membrana tectoria. Membrana tectoria. Now, I'll look at that one for you. Membrana tectoria. Okay, that one is also a remnant of what we call this, notochord. So we have apical ligament of Dens. We also have membrana. Okay, tectoria. Okay, that's one thing that you should know. Now, one more thing. We are talking about the remnants. There are some people, they have some kind of genetic, this kind of mutation, okay, in their system. So that the remnants are forming these normal things, they give rise to some kind of abnormal something. And my friend, that one is malignant. It is cancerous. Something we call chordomas. Chordomas. So whenever we talk about chordoma, then we are talking about the cancer of this guy, chordomas. Okay, so that's one thing. We expect that, you should form these normal things only and not lead to chordomas. But some people have some kind of genetic predisposition to develop in this rare, malignant situation. Now, one more thing. The other thing that I want you to also know is that over here, I've put this lab thing over here, which resembles the heart. Yes, my friends, above this procaudal plate, we see something called the cardiogenic area. Cardiogenic. And that's where the heart is going to develop. Then, my friends, I'm sure you'll be confused that, yes, how can the heart, this is the opening of the mouth by way of the procaudal plate, buccopharyngeal membrane, so should the heart develop above the opening of the mouth? My friends, that's where initially the cardiogenic area will be, until something called craniocaudal folding take place. And on craniocaudal folding, the cardiogenic area which will form the heart will come down, so that the heart goes into its normal place. Yes. Now, the more reason why I drew this guy is for me to show you something. That there will be perforation. There will be perforation of the mesoderm. I'm interested in the mesoderm. Perforation of the mesoderm everywhere. Okay, once the streak gives rise to this mesoderm, the mesoderm will perforate everywhere. Perforating mesoderm everywhere. Except two areas. And my friends, that's very important. I want you to know, except two areas. Mesoderm will perforate everywhere in this embryo except two areas. Number one is this guy over here, the region of the procaudal plates, becoming the oropharyngeal membrane, buccopharyngeal membrane, and then of course the cloacal membrane. Mesoderm will not be there. In other words, ectoderm and endoderm will be fused together. There will not be any intervening mesoderm in these two regions. Now, the reason is simple. Sometimes we've learned about this connective tissue, we learned about muscle, and we know that connective tissue and muscles, mainly they come from mesoderm. Whether it's primary mesoderm or secondary mesoderm, they come from mesoderm. And my friends, mesoderm, muscle, connective tissue, bones, cartilage. We don't need all those guys in this buccopharyngeal membrane or cloacal membrane. Why? Because at the end of the day, they should be thin membranes. They shouldn't be so robust so that they can easily be ruptured for the openings to be evident. Yes. And that is why God, in His own wisdom, ensured that during the perforation process, we did not have mesoderm going in these areas. Yes, that's one thing I want you to know. My friends, in other words, whenever we ask you of the composition of the buccopharyngeal membrane or the oropharyngeal membrane, as well as, of course, the cloacal membrane, your answer will be that they will be made up of only ectoderm and, of course, endoderm, no mesoderm. Yes. Now, the last thing for this meeting is that we've seen the primitive streak, yes, perforating and moving, yes, forming all these trilaminar germ layers. When they are done, they should regress. There should be regression of this, primitive streak. Otherwise, non-regression of the primitive streak, especially at the caudal end of the embryo, will lead to something we call sacrococcygeal teratoma. My friends, you got to understand that one. So, non-regression of the primitive streak, non-regression. Of the primitive streak will lead to something called sacrococcygeal teratoma. Now, my friends, this guy, although it is non-malignant, okay, it got to be removed surgically. Okay, otherwise the person may not feel very comfortable at all, because at the end of the day, if this is the individual, then what we see is that at the caudal end over here, we see this kind of, tumor growing over here, and that is your sacrococcygeal teratoma. Now, the reason why we see these things is that not only the streak, but we also see something something we call migratory cells. I'll be coming to these things. Neural crest cells coming in over here. Neural crest cells, something we also refer to them as the 4-germ layer. They will be coming in over here to invade. And that is why this teratoma thing we are talking about. You may see tooth, you may see hair, you may see a lot of things, okay, over here. Because all those germ layers, okay, can come here. And they give rise to all those structures over here. So my friends, this is what I have for you today regarding gastrulation. Formation of the gastrula, the trilaminar embryonic disc. I'm very grateful for your time this evening. Have a good night, all of you, and may the good Lord richly bless you. Amen.